Okay, let's talk a little bit about my latest design. I've dubbed the Gen 3. Been talking about it for the past couple of years now. Been promising, especially for you truckers out there, which this cell is really designed for. It's for the trucking applications. Try to help you guys save on fuel. Looking for a unit that runs really cool for long durations with a high hydroxy gas output. You guys are on the road almost 24/7, and you need a generating device that doesn't overheat. You can't be running at 180, 190 degrees Fahrenheit. You need something that's going to run cool for hours and hours on end. And so this is the design, as I discussed in my previous video, that I've been working on, and I explained that this basically was inspired by the six-pack. As you can see now, the six-pack is gone, and we now have in its place the new Gen 3 design. Okay, so the size, first I want to talk about how big it is. It's fairly large. I'm using 6x6 plates. The case itself is about 13 inches long. I think it's 10 inches wide and about 10 inches high. Okay, it's way bigger than it needs to be. But the reason for that is it's a prototype, and I wanted to make sure I had enough room to get into the different cell compartments, okay, to get in there with my hands and make all these connections and everything. For a more streamlined future design, it's going to be a lot smaller. I can afford to lose about 4 inches in height, probably another 2 inches in width, and probably a couple inches in length too. I can really squeeze this down. But for now, this is what we're prototyping. Okay, still got the battery packs in here, the 225 amp hour deep cycle batteries that cost 40 cents. Check my other videos. 40 cents to recharge these after they're fully depleted. 40 cents. And remember, the proof was here on this kilowatt meter that I've got that shows how much. It basically gives you all the parameters. I've already gone over it before, but this is definitely a useful tool that I've found to come in very handy. So 2-gauge cabling from the 2 iota battery chargers. Okay, so no overheating of any of the connections. They're all soldered. Everything, lock washers on the bolts. Same thing going into the cell. And notice that all the electrical connections are below the water line on this cell because we're running such high current. Okay. I don't want any chance for any kind of sparking, and this is also a Bob Boyce type of protocol approach where all the connections are made underwater, so there's no arcing of any kind to prevent unwanted explosions. Because this thing is putting out quite a bit of gas, and even though the water level's right up to about here, okay, there's about a liter of gas there. If that goes off, okay, it'll blow the top of the cell right off. Okay, as you see, I've got a panel here. Bolted down with rubber gasket material. I haven't really concentrated too much on this prototype as far as flashback safety, other than the fact that I've got this gigantium bubbler here that holds about a liter of water, and also in the front of the vehicle there will be another bubbler, but I don't have any explosive relief on the box as of yet. In the future, I'm thinking this panel right here will probably use nylon bolts, so if there is an explosion, the top will hold the top on with these straps, and if the top blows off, it'll break the bolts and hopefully hold the top down and just let the pressure escape without sending shards everywhere. But that's right now, like I said, you guys got to understand, this is just a prototype. Just like the six-pack was a prototype, this is not a finished design. This is just like with the Smack Booster, Gen 1 and Gen 2, this is an ever-evolving metamorphosizing project. It's going to change according to the data and the results that I record, and my customers' needs, and just plain old common sense. Okay, so here's the setup as you have it right now. Okay, so I have the battery chargers are plugged in via this outlet port right here, so they're both plugged in. When I turn the unit on, the battery chargers provide almost all the current. And the only time the batteries kick in is if the battery chargers are off. The battery chargers primarily provide all the current. And currently, the way I got it set up, they're each outputting about 25 amps apiece, and they come together at this one terminal here, one from each side. And at the combined terminal, it'll ramp up to, currently, it'll run up to about 50 amps. My electrolyte concentration I haven't stuck my pH meter in there since I did my original testing, but I'm going to tell you right now that there's a lot of lye in there, a lot of sodium hydroxide. Because of this parallel plate design, all wired up in series, it's taken a lot of concentration just to get my current up. But it is getting up. You know what? I don't care how much I have to add. As long as I get the gas output that I need, because this is a low maintenance cell. Once you set this electrolyte, because it runs so cool, there's very little water vapor escaping this cell. So the depletion of your catalyst is going to happen at an extremely slow rate versus previous design that ran pretty hot. After a couple hours, you're getting up to 90 degrees Celsius. A lot of your catalysts can get suspended in the water vapor droplets. Okay, this isn't happening with this cell. This puppy is super cool running, as I've kind of alluded to in some of my preliminary tests. I mean, I've never got this cell over 100 degrees Fahrenheit. Okay, it's never gotten any higher than that, which is it's unheard of for the amount of current that I'm putting in this thing. As far as I'm concerned, because as you guys know, I haven't dealt with dry cells. I don't build isolated series cells very often because the construction is too difficult and makes it makes it too hard to replicate. So this is the first combination parallel series cell that I've designed, and I'm really enjoying the low operating temperatures. Okay, so I'm gonna flip this puppy on real quick. You guys want to see what lots of gas looks like? You got to check this out. Look at that. Look at that. And it'll cloud all the way out down to the bottom. So already you can see there's a lot of bubble action going on. Okay, so that's what the production looks like.